All right, even in odd functions. We actually have covered this before in a previous chapter. And in fact, these are the two functions that I gave you to kind of help you remember which is even, which is odd. And again, if you look at something like a parabola, well, this is actually isn't a parabola. This is going to be a little snippet of a reverse cosine wave, which we'll be seeing in the trig chapter. But you could see there are similarities to a parabola. It's just simply that this one's going to keep going as a wave. But it is symmetric to the y-axis, and that's kind of the key. It's if I were to fold this on the y-axis, one side would lay right on top of the other side. So that would be symmetry to the y-axis. And notice what that says is that if I put a negative x in, then I get the same value as if I put a positive x in, okay? And you notice that if I run that line through, right, I get the same y value whether I put a positive x in or a negative x in. Okay, it's a really good schematic or diagram of even and odd functionality here. Odd, again, symmetry about the origin. And again, this is actually a sine wave we're going to run into in chapter 5. And you notice that again, if I plug in a positive x, I get this positive y value. If I plug in the negative x, I get the negative of the y value. Okay, so we've run into this before. And take a look at these examples. We've gone through these kinds of tests before. So really a lot of this has to do with even and odd exponents, right? So you notice that for A, okay, both the first exponent of this polynomial expression and the second one are odd, which means they're going to retain their negative identity when we apply that exponent. So I can tell you right now, I already know that this has to be an odd function because if I put in a negative x, I'm going to get the negative of y. All right? Okay. So that one works out. All right. Let's look at B. All right. And B, take a look at the fact I have an even exponent. That means whether I put in an even or an odd, it doesn't matter. It will stay, I'm sorry, positive or negative, it will stay positive, which means the function will never change. The function value that comes out of it will never change if I change the sign of the x input. So again, B then would be even, okay? And I'm kind of thinking of f of x is equal to x squared, right? It doesn't matter if I put in negative x or positive x, I get the same y value, okay? Now we're going to take a look at C. Notice there's a pattern here. I have a odd and an even exponent. So this is where I already know this is not going to work. This is going to be neither odd nor even because if I put in a negative, the 2x will change to a negative, but the x squared will not. Okay, so these are really not that difficult. You don't have to graph them to see it, but if you do graph them, you will see the symmetry. All right.